This past semester, I taught what we call Foundations of Data Science, essentially an intro to data science class. We had 10 students, mostly from math, but also some computer science, biology, and I think we had one business student as well. And what I want to emphasize is we taught this all in R, but I had one student who had used R before. So some had used MATLAB, some had used C++, but for the most part, they had no experience with R on day one of the semester. And so I want you to think about when you were starting to learn R. Right? For a lot of us, it was just hope to find a good tutorial, right? Maybe for those of us who are a little bit younger, hope to find some good YouTube videos, right? But we went through this course with the idea of, I want you to start learning to think like a data scientist. We're going to use R as a tool to deliver these ideas. We're going to use R so that you can execute these ideas, but the goal is to get you to start thinking from research question to insight. So I want to show 3 projects that some of these students did, and maybe spark some discussion about what do you think would be useful for students who are just now coming through school and getting to their first data science class. So this project was pretty cool. We decided, or actually, what happened here? Did I unplug something again?
Did your computer sleep?
My computer's not asleep. So anyway, I'll talk about this and then hopefully this will come back up. How many of us have heard of the IRIS data set? How many of us have used the IRIS data set? It's a very classic data set. It's very easy for a reason. How many of us know where the IRIS data set came from? Right? And so we get that a lot in data science classes. Just the professor gives us a data set and says, this technique is going to work great for this data set. Let's go use it. Well, what we did is we actually went to the Fullerton Arboretum and we looked at 2 different species of a genus called Encelia, which is native to California. It's in the sunflower family. And both of these flowers, or both of these species, have flowers with yellow rays, which is like the sunflower petals, and one's called Encelia californica, that's local to more coastal California, and one is Encelia farinosa, which is native to more inland California, but they look very similar. And so we decided to try to do something similar to the IRIS data set, but we're going...
She added a second go.
Oh, yeah, here we go. Just, okay. I don't know what's going on there. But we decided that we would collect the data ourselves rather than just use the IRIS data. And so we had students go in and decide what data are we going to collect. And so one of the things that they collected was the number of rays, essentially the number of what we would consider petals in other species. And so students counted in 50 of each. And they also looked at the disk diameter, so kind of the center of the sunflower. How long was that? And I gave them rulers, and they had to figure out what are we measuring and how do we measure it. As well as the ray diameter. So if you look at the entirety of the sunflower, how long is that? And so this student did some just basic EDA on looking at the difference between the 2 species on these 3 things. And as you can see, did some scatter plot and some lowest smoothing to look at combinations of variables. But I want to emphasize they collected this data themselves. Right? This is not the IRIS data where we know everything is going to work out perfectly. This is, we're building our logistic regression model and we're hoping that we can distinguish between these 2 flowers because we picked good variables to distinguish on. And so this was a project where we had no idea what we were going to get. Student went ahead and built a bunch of GLMs. We did not bother teaching the tidy models cross-validation. We just said, fit a bunch of models on your cross-validation. We taught them how to put everything inside the function rather than using tidy models. So the student fit, I guess, 9 different models and went ahead and did all the cross-validations. We always tell them compare it with a null model just so that you know whether you're actually getting anything useful out of these predictions. And the student ended up with a pretty nice ROC curve. So it's not as great as you would get with the iris data, but at the same time, this is actually collected data that we took a class day to determine what data we're going to collect and how we're going to collect it, and then do the EDA, and then the student finished up the modeling for his project. And so this is just an example of something that you could do to get students really interested in where does the data come from. Here's a second project. This one, I gave them data from the HCAHPS survey of hospitals for Center for Medicare Services. And this is survey data. It's really, really messy survey data because they give you each row represents like one summary item on the survey for one hospital. And so sometimes it'll give you the star rating for whatever the particular item on the questionnaire was. It will give you the percentage that gave you a particular answer to that survey question for that hospital. And then it'll give what they called the linear mean value, which was essentially their ranking of the survey data to get a number between 0 and 100, representing just generally how good the answers were. And so the students needed to do a lot of data wrangling. I think this was like a 150 meg data file. So not big data, but certainly bigger than anything that students would typically work with in a class. And the student went ahead and tried to plot everything against overall, just again, basic EDA, but the thought process is what counts here, right? Figure out what we want to plot. Then we've learned tools over the semester to go ahead and plot it. The student actually learned some patchwork. We went over that in class to talk about how can we put all of this into one figure. And yeah, I even showed them a light box, which is something that you can do with Quarto. And so you could actually click on the figure to expand it so that we can see it on the screen. So you guys are not looking at tiny picture here. And the student tried to build some models. We talked a little bit about using GT to make things like their coefficient estimate tables pop out. The student wanted to highlight the negative values. This, as you can see, was super collinear data. We didn't really talk about collinearity. That's not for an intro class. But the student was really happy to be able to get these coefficient estimates out for the multiple linear regression model and actually use GT to highlight what he thought was important for the negatives. This is the last project I want to talk about. This one, we had introduced some data on rent prices in Southern California as we were talking about things like how do we build a linear regression model, how do we do inference with a linear regression model. And so we had a group of students that said, for our final project, we want to go use Southern California rent data. The problem is the data set that I gave them was outdated. And so this is not something that you want to use for a final project if you're actually trying to come up with insights about things. And so we tried to scrape Zilla with R. For whatever reason, the R Selenium package and some other stuff wasn't working. And so the student just went on Redfin, got the table out, figured out how to use Excel to scrape the table of Redfin results, got that out in all of its messiness, put it in R, and then the student, along with a couple of teammates, actually produced some rent listings This is in all of its glorious messiness. So you can see we've got numerical variables that are absolutely not numerical. Some of the rents are a range of rents because it's for an apartment complex. And so the students did a whole bunch of cleaning with Tidyverse. So cleaned out a whole bunch of listings that did not have any, or that had empty data. And then here's her code for plotting the clean rent listings, and you can see that now we have numerical rent, numerical beds, numerical baths, numerical square feet. Stuart went ahead and did some EDA, and we talked about things like make your axis labels big so that people can see it rather than the default like 12-point font that you cannot see on a screen. Again, the student had some fun with GT, showing the green was really low rent and the red was really high rent, coming up with this insight that pretty much everything in Riverside is cheaper than Orange County and LA, right? But even OC for the data that she found was noticeably more expensive than the equivalent house or condo in LA, but for some reason that flipped for apartments. As she showed here with this visualization, you can see all of her outliers. Apparently she went into the data and found that house there is apparently in Disneyland. Or at least when she tried to geolocate the address, it was in Disneyland. And so we're not actually sure that that's a house. It may be like a storage facility that got listed.
Well, it's interesting because I feel like something like Newport Beach, you would find a rent like that, like if it were right on the water. So that outlier actually somewhat makes sense.
Yeah. This one here, I believe the students found that that one was a giant mansion in West Hills that was for rent at $20,000 a month.
Sorry. Is this data also capturing ADUs?
I don't know.
Yeah.
We suspect that there are some ADUs in this data set, but that's because she found things that were like a house with no bedrooms.
Right.
And so we think that's an ADU, and she just filtered it out.
Okay.
Yeah. And so, again, we talked about building multiple linear regression models. Again, this is their first data science course. It's the first time they've even thought about using LMs. Some of them had some introstats, so they knew about linear regression, but most of them had never done multiple. And I don't think any of them had done anything with indicator variables, especially when you have non-binary categorical variables. So we've got how to interpret county OC versus county RIV coefficients. And she goes ahead and talks about that. We really went into checking the residuals for these kind of models, not just getting like an RMSE out, but getting a histogram and then plotting the residuals, either a residual against the fitted values from the model or a more ML calibration check where you plot the predicted against the observed Ys. And then the student went ahead and talked about her favorite weird listings. This is the one somewhere in LA that it just looked like a bunkhouse. And so it was super, super cheap, shadily cheap. And it looked like you got basically one of 3 beds in a room, and that was what was going on. But this was my semester. We had a lot of fun with it. I learned a lot about how to teach intro data science, and I think I came up with some pretty cool activities. I'd be happy to talk with people or to field questions about what you wish you had learned as a freshman or sophomore in your first R class or your first data science class. Or just ask me questions in general about
this
the course.
class at Chapman or
This
what?
is at Cal State Fullerton.
Okay.
Yeah, so I don't know, does Chapman have an intro DS class?
You're looking at
I teach it.
You teach it?
You can teach it. Yeah.
So we should talk.
I have just one question,
Yeah.
kind of tangential.
Sure.
How would you define an insight?
An insight is, so the way that we thought about it when we designed the class is it's something that the data tells you that's relevant to the context of the question that you're trying to answer or the objective that you're trying to accomplish in the real world. So a lot of these, the insights aren't great because the data is just not very clean and very easy to extract insights from. But the idea is we wanted students to go beyond just, I built a model, I got a great RMSE, or I got a great mean log loss or whatever. I don't think we did mean log loss, we did Brier score though. But we want them to actually connect that back to whatever they were trying to answer in the first place.
What they struggle with the larger data set?
I think the biggest thing with the larger data set was figuring out what all the missing data signified. Because like I said, there were actually 3 columns that represented their 3 different things. We had the linear mean score, we had the survey star rating, and we had answer percentages. And those were 3 different columns, and only one of the 3 was ever populated.
Oh, okay.
And so trying to figure out what's the pattern of missing data, how do we actually condense this into a data set that we can use, that's what they struggled most with the bigger data.
So it wasn't a format issue where I have 3 features and then each one of those features only shows up once, but a complete data set would represent 3 rows? Or?
So if you think about, like, each hospital was represented by 10 or 11 rows, and within each of those rows, only one of those 3 columns had a number or a character in it.
And no idea why the rest was missing.
Well, the rest was missing because you would have one row that said like star rating, and then the column for answer percent and for linear mean value would be blank because it was about the star rating. And so it was just, you had to make sense of how the data was structured to be able to make any headway on it.
Okay.
Yeah, so just to finish up, I made them all push their stuff onto GitHub and build websites with GitHub pages. We had to take a whole day of class to get people's GitHub set up, but I would highly recommend if you're doing an Intro-DS class, this is an opportunity for the students to show off what they've done in the class. This is also an opportunity for them to put something on their data science resume, even after having only taken one course, that they can start shopping for internships and stuff with. Thanks.
Hello everyone, my name is Grace Kim and I'm currently studying Master in Business Analytics at UC Irvine. And I'm here today, I'm not here to share data tools or any technical insights, but I'm here to share a chapter of my life that might surprise you. And after 7 fulfilling years as working as an interpreter back home, I kind of made a bold decision to change my career completely into new data. So I made a bold decision to leave the career behind and embark on a completely new journey as a data analyst. And you might wonder why I traded the conference rooms and the translation for the spreadsheets or statistical models. And over the next few minutes, I will walk you through the experiences and challenges and some aha moments, and that convinced me this was the right leap for my growth. I grew up in a very small town in Korea. 99.9999% of the people around me looked and spoke just like me. So whenever I saw a foreign face on the street, my heart would light up with so much curiosity. I always wanted to talk to them with an English, but I couldn't because I had no idea a single word. So this longing actually drove me to study so hard this new language, English. So days and nights, I actually study grammar, pronunciation, alphabet, the reading, and And it's all because I want to become a kind of bridge to a wider world. And those kind of sparks of curiosity are kind of planted a seed of a lifelong goal, like to connect the cultures and to tell a story and break down barriers, one conversation at a time. And that dream actually came true when I pursued simultaneous interpretation in my master's degree back at home. And immediately after graduation, I was deployed into conference rooms in the wide range of the industry, like semiconductor, auto industries, mobile, and pharmaceutical, and chemical, etc. And working as a bridge of words between the executive, clients, or designer and engineers. And I loved diving into new fields and new industry. It was incredibly thrilling to help people and drive business simply by serving as a language, the language bridge. And seeing my interpretation quoted in the news articles and company presentation made me feel like a spokesperson and filling me with a big pride. And there was also exhilarating sense of accomplishment and delivering a message in real time on the conference floor. However, as I watched the GPT and the Google Translate advance at a lightning pace, I couldn't help but wonder, is my job really safe? And at the same time, a kind of a nagging doubt crept me in, like, am I nothing more than just a parrot, like echoing the other's thoughts and the voice? So after so many years in many organizations, I had my own thoughts that I love to share, but my role as an interpreter kept my voice muted. So that's when I was realized that I want to do work where I could deliver my own insights or idea directly. And when I look around the engineers that I worked with, some are in their 70s, and I thought that if people today live to 100, I mean, I was like only 30 with more than 30s ahead of me to live. So I need to build another skill set, like another weapon to ensure that I can, support myself in the decades to come. So I was kind of keep thinking that what should I study next? And then I found my answer, as you can imagine, in data. And I still remember that one meeting that I joined as an interpreter, and the one single objective number actually shifted the entire negotiation in this meeting at an instant. And I was so astonished. And while even interpreting, I was kept thinking how this number was calculated. And watching data-driven presentations sway executive, I realized how powerful data-driven story can be. And I couldn't stop asking myself, how could I use the data like that? And the more I thought about it, the more convinced I become. And this was exactly the moment that I realized that this is what I really need. So I kind of set a new goal for myself at the time, so to craft and deliver a persuasive message in my own voice, backed by data analytics. And that result brought me to the States, and then I applied to the UC Irvine for the master program. And today I stand in front of all the data people here and on this exciting new path. So, but once class actually kicked off last August, and every night felt like running through obstacle course. So statistics, mathematics, or the coding, machine learning. I mean, I stare at those like daunting terms and the tools, and then ask myself over and over, like, can I really do this? And more than once, I buried my head on the desk, like, in frustration. And the Python felt like a alien language from another planet. So every line of code was some puzzle that I could not decipher without my best friend help, GPT, the ChatGPT. So it was so tedious. I was wondering, like, if there could be ever end in this process, like would I be able to write the code fluently as much as I wanted? However, what kept me going on, that lifelong spark of curiosity. I pored over like error logs and late night in the night and plucked up the courage to ask professor questions and spend the hours debating concepts with the classmates. And each time a concept clicked, when the pieces finally into their place, I felt kind of rush of the excitement that lifted me back up. And then in this January, my capstone project had become the real game changer. I had a great opportunity to work with the Johnson & Johnson MedTech, the marketing department, and then we received the 5 years of sales, the data to find some insights and provide some strategic the recommendations. And we, with this data set, we build the chunk prediction model and the run clustering analysis, and we're going to deliver comprehensive KPI dashboard that can give them some insights for their sales the plan. And at first, when I received this data set, I was almost lost in hundreds of the lows in Excel sheet, because that was my very first time that I actually worked with a real data set. The most of the data set that I usually play with at school was, from something from the Takeo. So this was real, the exciting, the very, very the new moment for me. So for me, it was not so easy to find something insightful, but over and over running some models and doing a lot of visualization in Python, eventually some patterns began to emerge. And I remember leaning back in chair, thinking, oh, this is what makes data analytics so thrilling. And that was my first time that I felt some excitement about this whole process. And from that moment, I spent every week dipping the code and chasing down some fresh ideas, and the rush of discovering something new in the data become kind of a new source of my joy. And with the hands-on experience from my capstone and also my 2 years experience in the pharmaceutical industry, I applied to the data intelligence analyst internship role at a medical device company. And next month, I will be stepping into that role to put everything I learned at school into practice. And it's surreal to think 1 year ago, I didn't even know the first thing about the data. And I kind of wrestled with every concept and shed tears over, error logs and endure countless moments of frustration. But the hard work eventually paid off when I landed a small but very invaluable opportunity. So I overjoyed and had added such a meaningful milestone to my journey. And to be honest, I do not know how this journey will go and where I'll be and what role I will be playing a year from now. But I hope that on some future occasion, I'll be able to return to share my chapter with this R group here again and inspire somebody or motivate somebody who can also start their own journey. Thank you very much for listening.
Hi everyone, I'm Devyn. So when I was 16 years old, the doctors told my parents that I could drop dead at any moment. And I know that's not the typical opener for a presentation, but it was the moment that I realized that something needed to change. By the title, it might seem like I made my own startup. I did not, but it's on my bucket list. But I did crash, just like any startup would if they were under too much pressure. And so I'm going to be sharing a story about what happens when you launch too fast, you skip the recovery, and realize that version 1.0 is just quite ambitious. So I rebuilt, and along the way I learned a lot about systems, both human and technical. Alright, so I'd like to share a framework that kind of helped me reframe my experience through the lens of systems thinking. So there are 4 main components that I created Firstly is the front end, which is my persona, you know, how others see me. And then the back end, which is my mental health, you know, what's going on behind the scenes. The database, which is my long-term goals, so what I store, what I value and remember. And then finally, the API, which is my relationships with other people. So I'll walk through how each of these was built, and then they ended up becoming broken, and then I rebuilt again. So when I was 16, I graduated high school and essentially shipped my Devyn 1.0, version 1.0. And from the outside, you know, I had a strong GPA and was involved in things like leadership, but nobody saw my brittle internal state. So there was no margin for error and there was no observability. I didn't monitor my emotions. And I treated my goals kind of like KPIs. So my output was highly prioritized over my own well-being. And I like the metaphor that kind of like when you're launching a product with no crash logging, everything seems okay until it isn't. And so, you know, I had no maintenance window and I just kind of had the mindset of, okay, I'll just deploy again tomorrow. Okay, just a quick show of hands. How many of you have ever said that you were fine when you weren't fine? Yeah, okay, you guys get it. So on the outside, everything looks stable, right? But internally, you know, it looks like this. So on the outside, ChatGPT generated this lovely image of what life seems like on the outside and what it's really like. So that was me. In version 1.0, people saw somebody who was calm and grounded and just achieving. But privately, I would panic over small mistakes. You know, I couldn't relax or sleep unless I earned it, and I would just try to push through. So for example, on the outside in high school, I was taking a lot of AP classes, but on the inside, I was dissociating because of hunger and just being overworked. And it got to a point where masking my emotions was my default. So kind of tying back to a system design, my back end was essentially overloaded, and the front end, I just kept shipping updates. So that's when COVID hit. My dad almost died from COVID, and as a result, my mom and I managed every part of his recovery. So that was everything from his oxygen tanks, his nutrition, and calling doctors and just making important decisions. And I kind of put school on the back burner so that way I could fully focus on helping him. But once he recovered, I ended up collapsing. I didn't know what to do because I felt like I needed to be of use to somebody else. And I couldn't rest and I just didn't know who I was anymore. So I stopped taking care of my physical health and was having challenges with eating. And it got to a point where a doctor said that to my parents that I could drop dead at any moment. So this is a picture of me in the hospital. But during that time, I still didn't think that I was the problem. I just thought I needed to better optimize, you know. And an analogy I like to use is that it was like there was a fire in the server room. So my parents were watching me burn essentially, but they couldn't reach the source. And I had no internal monitoring to alert me until it was too late and I ended up in this situation. But then I started therapy, kind of like I start code reviews with a log dump. So I had myself pondering questions like, why is perfectionism my only setting? And why does resting feel like a threat? For example, in previous leadership roles, I did things myself. So I felt that depending on others was a lot riskier than quietly burning out on my own. But therapy kind of gave me this way to track my errors and gave me a feedback loop and helped me really trace the root causes of my experience so far in life. And so in terms of refactoring myself, I didn't destroy my system, I just iterated on it by including things like boundaries. So I turned off the always on mode, and then I did check-ins like journaling and therapy. I also scheduled rest that wasn't performance-based, so it didn't need to be earned, but now it's, you know, a part of my default in life. And then also I balanced it with being selective with my API exposure. In other words, not sharing everything with everybody. Yeah, I didn't want to swing the pendulum the opposite direction. And so like any good design, I structured it to be modular and I swapped components gradually. Today, I like to think that my system is resilient and not just high performing. So I realigned my database, and now I have values like purpose over productivity and integrity over perfection. I learned to clean up my APIs. I used to think that, you know, being a good friend meant always being available, but I realized that, you know, showing up doesn't have to mean overextending yourself. And also that recovery isn't a patch, but it's built into my design now. And I still run, you know, background checks, but I do it in a much healthier way. And these lessons are showing up in how I build now. So for example, I'm starting a job at TP-Link, and I know I'm going to be working with AI systems where things like safety and interpretability and resilience are really important. Also, in terms of my own projects, I don't just optimize for accuracy, but I check for things in my models like overfitting and bias and other potential blind spots. And in real systems, I add my own observability and explainability, and I question, you know, those silent failure modes and ask myself things like what happens if this breaks before I ship out a new feature. So as a final note, I don't believe that systems have to be crash-proof. They just need to be able to fail gracefully. And I'm not trying to be fixed, but I'm building a life where crashes are expected and my own logs are honest, and also that recovery is normal. I don't believe that we are broken code. I think that we're all living systems and that we're allowed to want to change our architecture. And so I just want to leave everyone with a few questions. This is just your time to, you know, pause, take a break, and maybe notice something in yourself that maybe you want to change that runs in the background. You can feel free to share if you have any thoughts, or you can just reflect on your own. Yeah. Thank you, everyone. If you have questions, feel free to ask or contact me, or there's my LinkedIn. Thank you.
Any questions? John, do you have a question?
Yeah. Everything you said is exactly the same things I've been through multiple times.
Really?
We're on John version 5, I don't know. It's glad that I'm really glad that you sort of figured this out younger in life. You're not alone. Everything you said, like I couldn't even do that exact same.
Oh, thank you.
What have you said that you built resilience into the system?
Yeah.
How do you do that? Because Devyn 2.5, which is I think the last one you're on now, like what does Devyn 3 look like? How do you know that when you're going to get there?
Yeah, that's a good question. I think one of the main things that has built resilience in me is building a support system. It's helped me understand that I'll be okay. Like things will happen in life, but I'll be able to handle it, and having that support system and, you know, people to remind me at times when it's hard for me to remember in the moment that I'll be okay has been really helpful in building my overall resilience.
Even though it's suboptimal.
Yeah. Yeah.
Do you feel like you needed to learn more about like computer science topics and stuff, like just this like full stack stuff just to think of life in this way more so, because like I feel like before I entered the world of computer science, like I really couldn't organize my thoughts as much as I could now. Now it's like when I'm cooking or something like that, it's, you know, coded and everything. I feel like I can code everything I'm doing. So do you feel like after you learned about computer science stuff, this is like kind of how you think of yourself, or did you generally think of yourself like in this like computerized way?
No, that's a really good point. I did not. Just after entering, you know, the EECS program, I feel like it's kind of changed the way that I think. I think more in like, not necessarily scientific method, but you know, just more methodical in my thinking, and I think that kind of has shaped my overall thought patterns when it comes to things, anything, pretty much. So, yeah.
Have you ever heard of chaos engineering?
No, is that like throwing something at the wall and seeing what sticks?
Yeah, kind of. So, but you just mentioned there that you tend to have everything linear and organized and stuff, and that's what I've done my entire life. And that's good until you put it into a chaotic system. So it's, I haven't seen it in industry, but it's in the literature. It's a software engineering technique where instead of sitting down writing unit tests to make sure every little component works and behaves properly and operates within a certain set of bounds, you just start randomly unplugging shit and see how resilient the system is to things. So it's like, I'm gonna go unplug this server and see what happens to the system. Can the system operate? Where does it fail? And that's how you do your testing, as opposed to a bunch of linear tests that you think about all the possibilities that can go wrong first, but you're gonna miss all kinds.
Yeah.
And lately I've been sort of thinking about putting that type of thing into my life.
In what ways?
Just let shit happen as opposed to trying to control it.
Yeah.
Not having all the unit tests saying my data is going to come in this format, and it's going to be, you know, normally distributed here and a Poisson distribution over there. It's kind of shit's going to come in, and most of the time it's going to be Poisson distribution, but other times it's going to be something completely different. Can I deal with that?
Yeah.
Without that crash and burn? Because that crashing and resetting sucks.
Yeah. I definitely agree. I think that's one of the main things that I've learned is that you can't control what happens to you. You can only control, you know, yourself, and the rest is out of your hands. So why worry about it? I mean, easier said than done, but yeah. Awesome. Thank you.
Give it 1 second. Oh, there you go.
Hi, my name is Takeo Shibata. So I'd like to thank you for this opportunity to share my works. I'd like to introduce the INDEX-TTS, fast, accurate local voice cloning system. It's from it's a system from recently published research paper. So I'd like to show you how it works. Okay, so I like to introduce myself first, but I don't know, as a demo, I like to let my avatar explain it, introduce me. I use like 2 open source libraries. One is the INDEX-TTS for voice cloning, which is today's my presentation topic. And the second is SATOKA based on stable diffusion for video generation. So that.
I'm a data scientist at a global food trading company where I build algorithmic solutions and apply AI across our supply chain. Outside of work, I've pursued acoustic analysis projects on my own, exploring signal processing and voice synthesis techniques. More recently, I've been applying AI to satellite data, developing models that extract environmental insights from aerial imagery. I've been working on speech technology since 2018, specializing in voice recognition and generative audio.
So again, like my avatar explain what voice cloning is. So
Say at copies someone's unique voice,
Let me see.
its tone, pitch, AI that copies someone's unique voice, its tone, pitch, and speech style, and uses it to produce new speech that sounds like them. A voice clone system has three parts: one that learns the speaker's voice features, one that turns text into sound tokens, and one that makes the final audio waveform. This lets us do things like give a voice back to people who can't speak, create custom voices for virtual assistants, automate narration for podcasts and videos, and bring game or movie characters to life with realistic dialogue.
Okay, I will explain in my own voice over next few slides. Here, it compares the Cloud API voice cloning service with a local open source offline system. Of course, the API service is easy to integrate. Generally, you just code API endpoint and then get the result. But it requires internet. And then it raises a question about privacy concerns since your data goes to the server. And then it has ongoing cost. And then usually no source code is disclosed. On the other hand, at the right side, the open source local offline system work offline, and then usually full data control, and usually open and the source code is available. You can tweak and change it, and then use it any purpose. They also only require one-time setup, but it requires the hardware power, typically 4GB GPU, or normally 16 or more. That's recommended. So I'm going to dive into the little bit INDEX-TTS technology. It's the research paper is originally from this. So if you need more technical detail, always you can refer to this research paper. But it's GPT style zero-shot model, and it's faster. And then it's also it's very natural. So I'm really surprised when I implemented it. It's very natural. I'm going to show you demo later. And then, but unfortunately, right now it's supporting only English and Chinese. Summarizing this, it uses three technical innovation. One is a hybrid codec architecture with FSQ, finite scale computation, and then it's conformer-based speech encoder. He also used the big BGAN for direct web form reconstruction. So we compare three open source library. One is the INDEX-TTS, only need a slide voice clip, run very fast, and support English, Chinese only right now. But it's under the Apache 2.0 license. So you can use the source code, run it, and then for even commercial purpose. The setup is pretty easy. The other hand, like a Cocky TTS, it's open, easy to install, but it's require a lot of the reference voice, and it takes long time. If you run it, it's 5 to 10 minutes, or sometimes 30 minutes required to generate the clean voice. But it supports 20 more languages. And then it's under MPL license. I think that you can use the source code for free, but unless you train from scratch, if you have to learn the already trained model, sometimes you have to buy the license. Usually the good quality license, you have to pay a license. So lastly, open voice. So it's also easy to set up. It's run first, and then it's also support multiple language. Voice control is pretty great, excellent. So you can put your emotion like sad, happy, angry. So it repeat like that. It make the voice reflect your emotion, and then also it's an MIT license. But I think that development is not ongoing. It's extremely difficult to set up the environment. So now I want to do the demo. So I'm going to don't know. You can judge for yourself. So how good it is. So first, I'm gonna play the original voice, Albert Einstein.
Position, not unlike to that of Alfred Nobel himself. Alfred Nobel invented the most powerful explosive ever known up to his time, a means of destruction by excellence. In order to atone for
Stop right now. And then first, you can listen to the open voice version too.
OREC is a meetup for all skill levels to explore and discuss our use in data science, visualization, mining, and predictive analytics.
So if the original reference voice and then the talk script, it generates like this. It generates like voice okay, but tone I don't think similar. So now I'm gonna play the INDEX-TTS.
Meetup for all skill levels to explore and discuss R's use in data science, visualization, mining, and predictive analytics.
So I think it's pretty good. What do you think?
Yeah.
So also like I played the Chinese version, but I don't understand Chinese, but
是一个面向各个水平的聚会，探索并讨论 R 在数据科学。
so even you don't understand the Chinese, but still you can tell like a tone is pretty similar. So it's kind of interesting because like you input the speech in language A, and then like talk script in language B, input the voice clone TTS system. It generates like a speech in language B with the tone of the language A speaker. So it's kind of amazing.
Position.
Sorry. So we go. It's pretty hard without this slide. Okay, I'm gonna jump into the live demo now. Let's see here. Okay, you input the talk script like here. Hi, our user. Our user group. I like to be our programmer. Please teach me our language. This is just like. Then you put the voice. For example, language people, Roosevelt, and then just for fun, like put the picture. Then you click on the lip sync. It takes like a 10 to 30 seconds to clone the voice, and then another 1 to 2 minutes for video clip generation. The environment is just 16 gigabit GPU, so same as like Google Bravo T4 environment. But anyway, so meanwhile, I'm gonna continue to
Can I ask you a quick question? What's the index part of the INDEX-TTS?
Well, index is like I think index part is my understanding is that index exists. They put like this structure. You put like all like web reconstruction and then input the this like text to speech language model. So that's my understanding. Okay, so let's continue.
Hello everyone, thank you for being here. I'll launch INDEX-TTS in my Streamlit app running entirely on my local machine with no cloud API or internet connection required. I'll enter welcome to INDEX-TTS and click generate, and in just a few hundred milliseconds you hear the text transform into speech, showcasing the one-click simplicity that makes INDEX-TTS perfect for rapid prototyping and secure air-gapped environments, while its low latency and natural prosody, realistic intonation, subtle pauses, and a hint of breath deliver lifelike audio that outperforms typical open source engines and rivals many cloud-based services, all while keeping your data fully local.
Okay, so now it's video is generated. Original voice is like this.
Senate of the House of Representatives, Yesterday, December 7th, 1941.
So that's the original.
That's the original,
Okay.
yeah. That's the Franklin Roosevelt World War II. And then, well, I'm gonna.
Hi, our user group. I like to be a R programmer. Please take me our language.
Oh, take. Oh, I misspelled it. Don't teach and take. Okay, anyway. So, I'm not sure the last one. Well, I'm gonna read my arbiter.
Only restores natural speech for individuals who've lost their voice due to illness or injury, but also empowers authors and media producers to instantly generate studio quality narration for audiobooks, podcasts, and videos without the need for a recording session. Distinctive voices for chatbots, smart speakers, and virtual assistants to deepen user engagement. Dramatically accelerates game and film production by allowing developers and directors to prototype. And dub character voices on the fly, all with just seconds of reference audio. And even lets you deliver presentations in your favorite foreign language flawlessly, like this slide presentation.
So also like you can use like any other like animated pictures. So I'm gonna play all of them, but just
In our progress so far, as a next step, I would.
okay. That's it. Thank you.
My name's Remy. I am a creative director by trade, but a scientist by training, which is strange. And I work with a lot of like tech companies and entertainment companies as a global head of creative, so I like make a lot of pretty stuff usually. But part of the reason why I'm good at my job is because I actually work in data a lot, and so I'm dangerous to myself in R and like Python. I understand how to like navigate a lot of information, and I usually use that information to like derive insights, which is kind of why I asked you about insights, because I'm curious how other people see insights. But usually insights to me are things that are non-obvious that exist in the world. It's usually like in front of you, but you have to like put it together to make something useful out of it, which is usually where data science and research come out of these pieces. So I used to work for, and as a little bit of disclaimer, I'm on sabbatical, which is why I'm kind of like floating around doing fun stuff that I think is interesting, which is why I found this. And I meant to come a few months ago, and I was like, oh, I'm gonna go now today. But I have worked as an executive at Amazon and Meta and a lot of like film companies like Universal and Sony, but I do a lot of guidance of large campaigns, like global campaigns for things, branding work for like Meta, and a lot of product design, all kinds of design related stuff. I used to also work for Shazam before we sold the company to Apple. And when I was there, even though I was based in LA, I used to work at out of the London office, which is the headquarters, a few months out of the year, a few weeks out of the year, really. And while I was there working on a big redesign of the entire app and the platform, I was having lunch with an engineer friend of mine, and he said something that was super interesting. While Shazam had this big thing that we had designed from the creative team that came from the data science team, essentially, which was, when you walk into their London office, there was a whole wall that was just the globe. It was a giant spinning globe that was like probably twice the size of this wall. And on that globe, you would see points of light flicking on and off every time someone Shazammed something in real time. And so it was like super cool, like at the time, because I don't think a lot of people were doing that kind of stuff. But you'd walk in and you see this thing where these were going off all the time. And when we were developing that, I used to like looking at the actual streams of data, because you could see the live streams if you got to shell into some machine somewhere, and you could like see like points of locations that people are literally like Shazamming some song somewhere. And I was talking to this buddy of mine that was an engineer in London. He was like, yeah, that's cool, it's a cool party trick, but I think it's possible for you to actually predict a hit that's coming. before anybody else knows it's going to be a musical hit. Because, and he started going into like very technical stuff that I started glazing over, but he essentially basically said, you could just take all the data, we could sit here and like pull it through Python and stream out exactly how far in advance we could predict a Billboard hit coming. And so I was like, okay, that's fantastic, let's do it. He's like, no, that's a tremendous amount of work. I'm not gonna get into that, like, that's ridiculous, I was just talking. And I was like, no, we gotta do it now. So it took me like a week and a few pub visits to talk him into doing it. He spent 2 days doing it. And it turned out that he was like, at first, he was like, it'll take a couple of days to maybe a couple of weeks, that's how like far out we could do it. It turned out we could do 45 days in advance. And it was so far in advance actually that we could predict a Billboard hit through Shazam before the label or the artist had any idea that they had a hit. And so he was like, this is really funny, but like nobody gives a shit about this. So like, what do we care? And I was like, no, this is a crystal ball. We have to like do something with the crystal ball. And so what I ended up doing was we actually built a completely new kind of marketing platform called Shazam Sessions, which was, we would take our marketing team, which was like a lot of like music marketers, very venerable music marketers, and call up like basically random artists. Like Hozier, for example, was one of our first people on the Shazam Sessions. And at the time, nobody knew who this guy was. He was very esoteric, weird dude. And we were like, hey, do you want to come to London and like perform for us? We'll have the studio set up, we'll have cameras, everything. We'll put it up on YouTube. You don't have to pay anything, we'll fly you out. And that turned into a very productive, very profitable, very exciting like process, because we launched a lot of hits that were from artists that nobody had ever heard of. I think Magic and like Lorde got her, because Lorde is Australian, New Zealand. But basically, this was all driven from data science, and it was specifically driven from our ability to pierce out an insight through the data and then yank it. And there was one thing that I'll kind of leave you with, which was one of the top data scientists at Meta when I was working there. He's even much bigger now, but he was an executive there. And he knew that I was fascinated with data. I for some reason, I love like real-time data, like when stuff is coming directly into you. And he was like, he would always tell me he was trying to explain to me why I liked this data, why I liked looking at the data, like what it was that I was seeing. And he was like, I love it too, but the thing you have to understand is data is not numbers. Data is people, and people are telling us stories. And that is kind of what I want to leave you with. That is the thing that is non-obvious, the insight in my career that I pulled out of data and like sitting with a lot of like very smart data scientists and researchers. And I thought I'd share it. So that's it. Thank you.